Raw data is any form of binary large object, blob data, or pre-structured data that is treated as a single sample for purposes of annotation. Examples include videos, images, text, documents, and geospatial and multidimensional data. When we think about raw data as part of training data, the most important thing is that the raw data is collected and used in a way relevant to the schema. To illustrate the idea of the relevance of raw data to a schema, let's consider the difference between hearing a sports game on the radio, seeing it on TV, or being at the game in person. It's the same event regardless of the medium, but you receive a very different amount of data in each context. The context of the raw data collection via TV, radio, or in person frames the potential of the raw data. So, for example, if you are trying to determine possession of the ball automatically, the visual raw data will likely be a better fit than the radio raw data. Output. In the realm of text data processing, the comparison between humans and software is particularly enlightening. Humans naturally excel at understanding the context and subtle nuances that are often embedded within the text. Our brains are adept at connecting dots, making contextual correlations, and drawing upon an expansive databank of past experiences and knowledge that are not immediately present to our senses. On the other hand, software operates within the constraints of its programming. While it can process text data, it can only understand the context and nuances to the extent they have been programmed into it. Software is reliant on the data fed into it, or the lines of code that are written to define its operational parameters, making it far less adaptive than the human mind in dealing with the complexities of text data processing. The real challenge then becomes overcoming our human assumptions around context to provide the right kind of data for software to process. It is crucial to acknowledge that while software can handle vast amounts of data more accurately and efficiently than humans, it lacks our inherent ability to understand context and nuances in text data. This complexity presents an ongoing challenge in the field of text data processing. So how do you do that? One of the more successful ways is to start with the schema and then map ideas of raw data collection to that. It can be visualized as a chain of problem. Schema, raw data. The schema's requirements are always defined by the problem or product. That way there is always this easy check of, given the schema and the raw data, can a human make a reasonable judgment? Centering around the schema also encourages thinking about new methods of data collection, instead of limiting ourselves to existing or easiest to reach data collection methods. Over time, the schema and raw data can be jointly iterated on. This is just to get started. Another way to relate the schema to the product is to consider the schema as representing the product. So to use the cliche of product market fit, this is product data fit. To put the above abstractions into more concrete terms, we'll discuss some common issues that arise in industry. Differences between data used during development and production is one of the most common sources of errors. It is common because it is somewhat unavoidable. That's why being able to get to some level of real data early in the iteration process is crucial. You have to expect that production data will be different, and plan for it as part of your overall data collection strategy. The data program can only see the raw data and the annotations, only what is given to it. If a human annotator is relying on knowledge outside of what can be understood from the sample presented, it's unlikely the data program will have that context, and it will fail. We must remember that all needed context must be present, either in the data or lines of code of the program. To recap, the raw data needs to be relevant to the schema. The raw data should be as similar to production data as possible. The raw data should have all the context needed in the same